Good morning, everyone. Just wanted to take a minute to talk a little bit about the triangle inequality and angle side relationships in triangles. So really what we're going to be doing now is we're kind of shifting our focus towards inequalities in triangles. These concepts are not inherently anything bigger than what you would have already known. We're just kind of applying them within triangles. All right, so there's really nothing new. It's really the hardest part about this will be determining which side and which angle you're dealing with. So ultimately, what's our goal? So our goals for this section are really to utilize inequalities to determine relationships in triangles. And we're going to explain whether or not three segments can even form a triangle to begin with. So those are the two main things we're going to focus on throughout this. So where we're going to start is here I have a picture, a lovely little Desmos drawing of a triangle. And when it loads, you'll be able to see that the triangle itself has all of its angles measured and all the sides measured. So we're just going to kind of play around with this for a little bit. As I move B, obviously, as you can see, as I'm moving B, this length's not changing. The angle is, right? But the length itself is not necessarily changing. And now if I'm moving C, the length of AB is not changing. And if I'm moving A, the length of BC is not changing. So that's something very important to consider. When you're looking at angle A, you care about the side length BC. When you're looking at angle C, you care about the side length of AB. When you're looking at angle B, you're caring about the side length of AC. But let's also take a quick little moment to look at the angle measures, right? So the smallest angle is angle C, 38 degrees. We know that all of them must add up to 180. And it is opposite, and by opposite, I mean if I were to draw in a line, right, it is opposite AB, which is the shortest side. Okay, it is opposite the shortest side. Similarly, angle B here, which is the largest angle at 98, is opposite the longest side, AC. All right. So based on what we're seeing here, and this one's in the middle, A is in the middle, and its side length's in the middle. We can kind of predict that if you have the smallest angle, it's going to create the smallest side. The largest angle, largest side. And let's just see if that holds if I kind of move this around, right? I'm going to make A the biggest. So A is now the biggest. C is now the smallest. Oh, it always was the smallest. Let's make C the, well, that doesn't seem to be happening. Okay, whatever. So we have that A is the largest now, and it is opposite the longest side. Okay, B is in the middle. It's opposite, right? And by opposite, I mean the one across from it, the middle side. And C is the smallest, and it's opposite the shortest. Okay. So that's a actual formal relationship that we have. So if we look back at our triangle slide, these are what are called the triangle angle or the angle side relationships involving triangles. All right. So if we know that this side is bigger than this side, right? So if we know XY, which is 9, is bigger than YZ, which is 7, we know that the angle opposite the 9, which is angle Z, is going to be bigger than the angle opposite the 7, which is X. Okay. So what can we do with this? Well, we can use this to put the sides of a triangle in order, right? Because obviously, let's say this one was 8. Clearly, if you were to compare this one, this would be bigger than this, but it's bigger than this. So you would end up essentially getting these in the middle. All right, so you can use it to get the ordering of them all. The hardest part about this is remembering which angle goes with which side, right? So think of it this way. X, you're going to use all three of the letters that you have when you're putting these in order, right? So XY is on the left-hand side on this one. Z is not going to be on the left-hand side on this one. All right. The same holds if you go the opposite direction. If you have that 110 is bigger than 45, you know that KL is going to be bigger than JL. All right. So these hold. So let's actually do something with these. So we're going to put the sides of the angles in order. On this one, we're going to put the sides in order. All right, so first of all, we need to figure out, well, what's the measure of angle A? Well, we know that all three of these added together have to be 180. So 30 plus 65 plus measure of angle A equals 180. So that would be the measure of angle A equals 85. Okay, so that is 85. So I'm just going to put the angles in order first. So the measure of angle B is the smallest, right? 30 is the smallest. And then we have the measure of angle C. And be careful, my angles and my inequalities kind of look the same. And then the measure of angle A is the largest. Okay, so that is the largest. Now we're going to use that to write the sides. So we have B, C, A. So remember what I said, the two letters that are not used with this, right, are going to kind of represent the side, right? So if we have the measure of angle B, the opposite one is AC, right? So we had B here, now we have AC. AC is going to be the smallest. Now C is in the middle, which would make AB the next in the middle. And then BC is going to be the largest. All right, so that's how we do that one. Now this one, we already have the sides in order, or we already have the side lengths, I should say. PQ is less than RQ, which is less than RP. So now what do we need to do? We need to put the angles in order. Okay, so if we have if we have PQ is the smallest, the angle opposite that is R. So the measure of angle R. And do you see what I mean with, we have PQ, now we have R. Right, we have RQ, so now we're going to have P. RQ, opposite one, P. Which is less than the measure, and what's left? Q. Angle Q. Okay. So simple enough. There's really not a whole lot that we have to worry about in terms of computation in this. It's really just a matter of, adding up to 180 if you need to do something like that. On an occasion, you might need to find a side length, but that would really only kind of come down to like if you have a Pythagorean theorem or you have enough information. There would be something explicitly given to you that would provide you with information at the side length. All right. So let's move on to the next part, the triangle inequality. Now, this is actually going to determine whether or not three lengths can make a triangle. And in order for any three lengths, to make a triangle, they have to satisfy all three of these. Okay? If they fail any of them, these three, this would not be able to be a triangle. So what's it saying? It's saying the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay? So what it's saying is if the measure of A, the length of A plus the length of B has to be greater than the length of C. The length of A plus the length of C has to be greater than the length of B. Length of B plus the length of C has to be greater than the length of A. And if they don't have that, it wouldn't be a triangle, right? If you kind of took like little sticks or something of those lengths and tried to put it together, it wouldn't meet. The case that is a little bit hard to see is what happens if they're exactly equal, right? What if you got that A plus B equals C? Well, that doesn't fit this, right? It requires it to be greater than C. That's kind of the situation where like it looks like it's going to be just perfect, but like it's not quite, right? It'd almost be like a box, like a perfectly folded box. And the only reason it's staying together is, right, you have the tape across the top. So think of it that way. Okay. So we have to satisfy all three of these. So let's practice. Are these triangles? Well, how would I figure this out? I have to figure out if 2 plus 3 is greater than 6. Is 5 greater than 6? No, it's not. So it's not a triangle. Now, for this one, let's figure out 7 plus 10 is greater than 13. 17 is greater than 13. Okay, so far so good. But I have to check all three. If I don't check all three, I could miss it on one of the other ones. Okay, 20 is greater than 10. That's good. And then finally, we would have 10 plus 13 is greater than 7. 23 is greater than 7. Okay, so we are good. So that's a yes. Turn my check mark into a yes. All right, let's check this one. 5 plus 9 is greater than 10. 14 is greater than 10. Okay. 9 plus 10 is greater than 5. Well, that's definitely going to be true, right? 19 is definitely greater than 5. And then we have 5 plus 10 is greater than 9. Now, obviously, I'm going through the process of showing you how you would check to be 100% certain. There's obviously shortcuts you can figure out, right? Like 9 plus 10 is going to clearly be bigger than 5 when both 9 and 10 are bigger than 5. Really, the big thing that you want to check is the two smallest ones bigger than the third one? But I'll go through the process of it as well. All right, so 16 plus 19, well, I'm not even going to bother doing that adding. That's clearly bigger than 3. Okay, 19 plus 3 is definitely bigger than 16. That's true, right? 22 is greater than 16. And then we have 16 plus 3. Is it greater than 19? No, it is equal to 19. As we said, if it's equal, it does not work. So this is a no. So these three sides would not make a length, would not represent a triangle. Okay. All right. Last thing, let's see if we could figure out the range of the x values. All right. This is a little tougher because there's a little bit of reasoning we have to kind of use on this one. So we have that, again, using the triangle inequality, we have to know that's true. We also must know this. And finally, we must know this. Okay, for this to be a triangle, all three of these must be true. So we have to find basically what numbers will satisfy all three of these inequalities. So let's simplify this. If I subtract the 8, I get x is greater than 4. If I subtract the 12, I get x is greater than negative 4. And on this one right over here, if I rewrite it, that's x is less than 20. Okay, so what are we looking at here? Well, essentially, if I make these different colors, I'm going to make this one pink. Okay, so if I draw a number line, here's 4, greater than 4. I need to be greater than 4. Okay, simple enough. Negative 4. I have to be greater than negative 4. Okay, so we've already encountered a problem here, right? We have to be both greater than negative 4 and greater than 4. Just kind of using your reasoning skills. In order for both of these to be true, right, it would have to exclusively be bigger than 4. So essentially, this isn't going to give us any new information, right? Because if I picked a number like negative 3 is bigger than negative 4, but it's not bigger than 4. So this doesn't give me any additional information. All right. And the last one here, we have to have x is less than 20. So if I go over to 20 here, all right, it goes this way. So this area right here between 4 and 20 is what will work. Okay. So the area between 4 and 20. So my x values would be, you could write it in this regard. Okay. So any number between 4 and 20 will make these sides true. All right. Okay. So that's everything you need to know about the triangle inequality and angle side relationships. Please let me know if you have any questions. Have a good day.